Okay, so here we are on this last problem, and we've flipped it around on you. Instead of having to solve for the solutions or to find the given roots, what we've done is we've given you two possible roots, and we've asked you to write a polynomial function of least degree. Now, that term right there is extremely important, because there's probably a ton of higher degree polynomial functions that have 2 and 1 minus I as a potential root. But what we want to do is write the polynomial function, the smallest possible polynomial function that we can with those two roots in them. So we're going to move forward from here, and if you remember the conjugate pairs theorem, it said if we have one complex root, that we have to have the conjugate root as well. So that is extremely important that we understand that in writing this polynomial function. So here we go. I'm going to start this off. What this is basically telling us is that we know that x is equal to 2, and we know that x is equal to 1 minus I. The conjugate root, the conjugate pair theorem tells us that we also have to have the conjugate as well. So we have 1 plus I. Now, if we want to write a polynomial function, we can use the zero product property, but we're going to do it backwards. But first we have to convert these. So I'm going to say x minus 2 equals 0, x minus 1 and plus I equals to 0, and x minus 1 and minus I equals to 0. Now the reason I did that is because once all of these expressions, all these terms are equal to 0, I can then multiply them together. So I can say x minus 2 times x minus 1 plus I times x minus 1 minus I is equal to 0. So that's the reverse of the zero product property. Now, this is just basically a straightforward process of multiplying polynomials here. So what I would suggest you do is multiply the two trinomials here. They're kind of complex terms, so it's going to take 3 distributions here. So I'm going to go ahead and work that out. It's kind of long and obnoxious, but you can go ahead and try it on your own and take a look in just a second. Okay, and you can see here that we got kind of crazy with the distribution, and we ended up with all these terms. But you'll notice that looking through this, you actually have quite a few terms that cancel each other out. We have a positive I and a negative I. And so you can see here we have the negative I squared, and if you remember, I squared is equal to negative 1. So we'll go ahead and rewrite all these terms out. Okay, now that I've condensed that down to its simplest trinomial, now I'll need to distribute the x minus 2 across that trinomial. Okay, and I've finished writing this equation of the polynomial function with the least degree. Now, at this point, you just need to be real aware of the technicalities of things, and this can be a little ticky-tacky, but the directions actually asked us to write a polynomial function. So I guess if we're going to be technically correct, we should write this as f of x equals. And that would be our polynomial function of least degree. So that is kind of the opposite process of what we've been doing. That's something that you need to be able to do. I know it's a little long and drawn out. Now, what I've done here is I want you to take a look at this. I'm going to show you a second method of this. So once we get to this part right here, I'm going to give you another option here, and I want you to see this. If you'll notice, I put x minus 1 in parentheses, and then what we have is, since I have an x minus 1 term, this is an a plus b term, and this is an a minus b term. A plus b and a minus b is a difference of squares, and so that would lead us to a squared minus b squared when we multiplied it together, which is where I got this particular term. And then I could do the x minus 1s that way, and if you notice, we end up with the same value there as we did in the previous one. So if you like this method better, by all means, please use it. It's not as long and drawn out as the previous method. There's nothing that says that you have to do it this way, as long as you get to the same part there, same final answer there. So anyway, that's another type of problem that you could see on your unit test.